Okay, so now let's take a look at insertAfter. Okay, so the idea of insertAfter is that we're given an iterator and a value to insert in our list, and then we insert the new node after the iterator. And there are basically a few cases we need to support here. Three main cases. I might want to insert at the head, or in other words, before the existing head. And if you recall, we do that by passing in a null iterator. And when we pass in a null iterator to insert before the head, there actually could be two cases there. It could be that I have an empty list and this is the first thing I'm inserting in the list, or it could be I already have things in my list. So there are both of those cases we want to handle for this. This first case has a subcase. The second one is that maybe I'm inserting after the tail and I'm adding something new to the end of the list. Well, that's basically the same as append, and we already know how to do that. And then the third case is maybe I'm inserting in the middle between the head and the tail, but not before the head or after the tail. Logically, strictly between the two. So those are our three cases. So let's take a look at them. Let's say we're inserting at the head. Well, if I'm inserting at the head and it's an empty list, then it's going to look like the code we just wrote for append. First, we add a new node. Then we set head and tail to point to that new node, and we're done. Okay, or I may already have something in my list. In that case, let's say I already have milk, and I'm going to add bread into this list. So when I create this new node, and let me just point out here that, again, the iterator is going to be pointing to null. And so that's what's cluing us in that we're inserting at the head. So we create bread, and when I create this DList node, I'm going to go ahead and set next to point to the current head, because I know that there's an object there, and next should be pointing to it. But previous, this is going to be the new head, so previous should be null. So I just omitted the previous pointer in this constructor, assuming it's going to get set to null automatically. Okay, then the next thing I need to do is make sure that the node that's existing, I need to update its previous pointer to point back to bread. Okay, this node milk is the tail of the list, and so I should be able to follow from the tail, from previous, to previous back to bread after I get finished updating the whole list. So I need head previous equals the node. So I follow the old head to previous to point to bread. Right, it adds this link. Okay, and then the last step I need is to set the head pointer to be the new node, because it should be the new head. Okay, and after I've done these three operations, then I have this new bread node. I can follow the head pointer to bread, and then its next pointer to milk, and then I get null, so that's what it should be. I get bread, then milk, then null. Or if I start at the tail, I start at milk, and then I follow its previous pointer back to bread, and then I follow its previous pointer to null. So I have those two lists set up properly, one the reverse of the other. Okay, so that's our first case. Either inserting at the head of an empty list or inserting at the head of a non-empty list. Okay, or I could, in case two, I could be inserting at the tail. And so if I'm inserting at the tail, in general, this is also like an append. And so I'm going to add a new node. And the first thing I need to do is detect that I'm inserting at the tail. And the way I detect that is I look at where the iterator is pointing. And if the iterator is pointing at the same node the tail is pointing to, then I'm inserting at the tail. So that's an easy thing to check. I just need to compare tail equal to it.node. And if they match, I'm inserting at the tail. And then I just follow the append steps. I allocate a node whose previous pointer is pointing back to the current tail. Then I update tail next to point to this new node. It draws in that link. And then I set the tail to point to the new node to finish indicating that this new node is in fact the one at the tail. Okay, and if I follow the pointers, then I see that I set up the list properly, because from the head I go to milk, then I follow the next pointer and I get to bread, and then that's null. Or I can start at the tail, at bread, follow the previous pointer back to milk, and then get to null. So this is all set up properly. Okay, and then the last case is inserting in the middle. And it's kind of hard to draw this in a nice way because I don't want to make lots of changes and move objects around too much. So I kept the objects where they were so you could see the arrows being added. Okay, so if I'm inserting in the middle, then basically what I have to do is rewire the links of two existing nodes to point to a new node that's going to be between them. And the allocation of that new node is fairly simple. I can say that I'm going to add a new node eggs in between milk and bread. And so when I allocate that new node eggs, I'm going to set its next pointer to point to bread, which would be whatever comes after the iterator, right? So IT node next would be bread. So I start it pointing out to bread, and I set its previous pointer to be whatever the iterator is pointing to, right? Because I'm inserting after that iterator. So that's just IT node. So when I build this object, its next pointer is already pointing to bread, and its previous pointer is already pointing to milk. And so now all I need to do is make milk point to eggs through its next pointer, and bread's previous pointer point to eggs. And then everything will be set up properly. Okay, so I can update milk's next pointer by using this iterator. So I can say it.node next, it.node arrow next equals node. And that will establish this link to eggs. And then we can say, we can use the pointer we have to our new object, right, called node, and follow its next pointer to bread. So node next will take me to bread, and then previous takes me to its previous pointer, node next previous, and then I set this equal to node, and it creates this link pointing to eggs. Okay, now just to check that everything's working, I follow the head pointer to milk, I follow its next pointer to eggs, I follow its next pointer to bread, and then its next pointer is null. So that's a complete list with everything. Or I can start with the tail pointer, and that starts me at bread, and then I follow its previous pointer back to eggs, and then its previous pointer back to milk, and then its previous pointer to null. Okay, so the list through next and the list through previous are complete, and they're the reverse of each other. And so the operations I took here to set this up work. Okay, if we write all this out, then I basically have these three cases. The first case is if I have a null iterator, it means if it.node is null pointer, that means I'm inserting at the head. And so this code takes care of inserting at the head. If the iterator is equal to the tail, that means I'm inserting at the tail. And else, it means I'm inserting in the middle. Okay, so for inserting at the head, we have our two cases. We can either be inserting to an empty list, which is this first case, head is null pointer, or I'm just appending, I'm just inserting at the beginning. And then here, right, if I'm inserting at the tail, then this code is equivalent to the append operation. And then finally, if I'm inserting at the middle, then I just need to allocate the new node and set up the links on either side of it to point to it. Okay, so that's insert after. It's a little more involved than insert after on a singly linked list. We just need to think through, where the links are going and how to keep the next pointer and previous pointer up to date in each one of these cases.